FeatureCam 2014 also introduces the automatic avoidance of clamps and fixtures for 3D roughing and finishing. The ultimate aim is to make collision-free programming as easy as possible. Clamps are chosen in the same way as for simulation, but now we collision check against them using a new option in the machining attributes. The amount of clearance can also be individually controlled by setting separate radial and axial allowances. In this example, we have an alternator bracket that we wish to machine. If I go to the part view, you'll notice we have a facing operation and a Z-level roughing operation over the entire part. This operation also takes into account two different tooling operations, cutting with a 20mm tool and a 12mm tool. If we go ahead and play a 3D simulation of this, we can see the toolpath works its way down through the components like so. However, in this particular instance we have a vice that's holding the component down. If I go ahead to my layer dialog, turn on the vice layer, set the shading on, we can see the size of the vice and the position of the component like so. In this case we're going to select all of the vice components, right click and say use solid as clamp. Now when I simulate, if I go and turn on my holder and my collision checking, do a single step, my vice appears in simulation and I can play my simulation through. However, as I get so far down the component, you'll notice the tool is starting to gouge with the vice, and will continue to do so unless I make some changes to my toolpath. Now in the past I would have had to select all the faces of the vice and do some kind of collision checking against them. Now I can go to my manufacturing options, into the machining attributes, and under the milling tab we have a new button that says clamp avoidance. By selecting this I can turn on my automatic clamp avoidance, and I can set an allowance value. In this case I'm going to set it to be 3mm. We can also choose a separate axial allowance if we wish to do so. By selecting this option, the original allowance becomes the radial allowance. Let's say OK to that, and accept, and recalculate the toolpath. So now we can see, as we recalculated the toolpath, we've left material around the vice and got a collision-free process throughout.